Good morning, afternoon, esteemed educators and budding programmers. Today, we delve into the core of programming, where ideas morph into tangible operations. Our initial focus is on the fundamental concept of variables, the bedrock upon which programs are built. Imagine a variable as a box, a modest box, yet potent in its capacity to hold something invaluable: information. In programming parlance, variables are containers designated for storing data. Each variable boasts a unique name, acting as its identifier, much like our names serve as our identifiers. Now, these arena URTMT, just ordinary boxes. They are specialized containers, some tailored for holding numbers, while others are designed for text. The reason for this differentiation springs from the nature of the data they hold. The input command harks back to the dawn of computing, when the straightforward term input was primarily used to introduce data into your basic program. In today's age, with the advent of graphical user interfaces, we've moved beyond the traditional input that took up a section of the main screen. Instead, data entry is facilitated through an input box presented in a distinct window. Let's explore a few examples to elucidate this transition. In the realm of the Smart Package robot, there are two primary input commands: GUT, or Get User Text, and GUP, standing for Get User Password. However, the functionality doesn't stop there. Users can also extract text directly from the clipboard. And going beyond text, the Smart Package robot can retrieve images from the clipboard using the ANA. From clipboard command. This multifaceted approach ensures versatility in how data is sourced and processed within the system. Regardless of the source, all input eventually finds its way into a variable. Once housed in this variable, the data can be channeled to various destinations, be it displayed on a screen, processed for analysis, or directed to any number of output options. Essentially, a variable acts as a conduit, capturing input and facilitating its journey through the system until it reaches its intended output. Hello people, how are you doing? Let's talk about variables. Hello people, how are you doing? Let's talk about variables.
Hello people, how are you doing?
The core concept behind data processing can be distilled into 3 fundamental steps. First, you input the data, then you process this data, and finally, you output the data. With the Smart Package robot, the range of output destinations is vast. As delineated in the Input-Output Commands section of the help file, there are several avenues to explore. For instance, text data can be directed to the clipboard or transformed into a dial tone for telephones. For more interactive feedback, there's the option to present the data through a message box or, for timed alerts, a message box timed. If auditory signals are more apt, the message beep function can produce tones. Other alternatives include dispatching the data to standard output or even printing it with the PRTprint command. In a more dynamic turn, the Smart Package robot can vocalize textual data akin to what you're hearing at this moment. Additionally, for visual emphasis, there's the Show Bubble Text feature AEUR, crafting charming bubble text annotations suitable for buttons or other elements. And for those urgent alerts, Show Text can project large, colored text signs onto the screen, ensuring the message is hard to miss.
Hello people, how are you doing?
These 3 dashes make the voice to pause.
Cześć ludzi, Jaxi Messi. Ty 3 myślniki sprawiają, że głos, pauza.
Some of these features are as well useful for debugging of scripts. We will see some examples here.
Hello, people. How are you doing?
These 3 dashes make the voice to pause.
Cześć ludzi, Jaxi Masi. Ty 3 myślniki sprawiają się głos. Pauza.
How do variables get born? Technically, there are 2 pivotal steps, declaration and definition. Both of these steps must be meticulously executed before a variable can be put to use. Declaration, in essence, is akin to sending an announcement to the compiler, proclaiming the existence of a certain variable. At times, this also entails specifying the kind of data the said variable will store. When we talk about strings, declaring essentially means you're making a solemn promise to the compiler that a designated variable will house a string. Now let's discuss definition. Definition is the act of allocating a dedicated space, a niche, for the string in the vast world of memory. When you declare a string, the system, acting as a dutiful custodian, earmarks memory space for it. However, this space remains barren, almost like a canvas waiting for its first brushstroke, until you define the string and bestow it with a meaningful value. It's paramount to understand that in a multitude of programming languages, including with the SPR, these 2 steps, declaration and definition, often dance in tandem. They can be executed simultaneously, streamlining the process. When you peruse the Smart Package Robot's help file, you'll stumble upon a section titled Variable Definitions and Operations. Within it, you'll uncover commands for declaring and at times defining variables, including text variables for the Smart Package Robot script, and generally, simply typing a variable name followed by equal sign, and text defines a text variable. The Smart Package Robot, by design, often discerns whether the input data is numeric or textual and acts accordingly. However, if you desire precision over automation, the toolset expands. There's the variable numeric command to explicitly declare a numeric variable. For a deeper dive, commands like variable floating point, or VFP, and variable integer, VIN, allow you to specify between integer and floating point data. Internally, as revealed by the GVT getVariableType command, the Smart Package Robot juggles 8 variable types. The key numeric types include Type 2, which is longinteger, 32-bit, Type 4, the 64-bit signed integer, and Type 5, the extended precision floating point. The primary data type, however, is Type 1, the string data type. In essence, this intricate architecture is how variables breathe life within the Smart Package Robot. Now let's ponder upon the cycle of life, even in the world of programming. Anything that is birthed, that sees the light of day, is inevitably destined to be reclaimed by the abyss of oblivion. In simpler terms, most variables that are conceived during the runtime of a script will meet their end, be automatically vanquished when the script concludes its journey. This signifies that, post the script's culmination, the computer embarks on a cleansing ritual. It liberates the memory that was previously occupied by the data residing in the variables. Moreover, it also releases the memory that cradled the variable names and the data delineating the variable's coordinates in the memory realm. However, in the vast lexicon of commands, there exists one that empowers us to explicitly obliterate a variable, erasing both its essence and content from the memory tapestry. This command goes by the moniker variable once, or the vow command. While this command is a multifaceted tool with diverse applications, one of its standout uses is the precise deletion of a variable. When navigating the vast seas of data processing, one seemingly minute detail stands out with paramount importance: AUR, the length of a string. Why, you might ask? In the realm of the smart package robot and similar systems, the LEN. Command serves this very purpose. By utilizing LEN, one can precisely determine the length of a variable, ensuring consistent and accurate data operations. Imagine a library with countless books. Without knowing the number of pages in each book, organizing, referencing, or even simply reading them becomes a daunting task. Similarly, in programming, strings are like these books, and understanding their length is akin to knowing the number of pages. The length of a string is not just a numeric value, it's a beacon of structure and predictability. By ascertaining a string's length, one can allocate appropriate memory, ensuring efficient storage and preventing potential system overflows.